Hello everyone. In this second video, we will talk about Newton's second law of motion. In order to understand Newton's second law of motion, we will have to understand momentum and acceleration. You must have noticed that when we are in a shopping mall, it's easier to start pushing an empty shopping cart than a full shopping cart. But once you start, it's easier to stop the empty one than the full one. Why is that so? This video will help us answer that question. Let's perform an activity and find out more about it. This is a Newton's cradle, which explains momentum beautifully. These metal balls are of the same size and the same density. Their masses are also the same. Hence, they transfer energy to each other very visibly. It's the easiest way to understand the conservation of momentum. Observe this Newton's cradle. If we vary the number of balls, what will happen? Let's find out. If I release one ball from one side, one ball gets pushed out. If I release two balls from one side, two balls from the other side get pushed out. Now what will happen if I release three balls from one side? Three balls will oscillate. This is happening because the momentum is conserved. Now what will happen if we vary the size of the balls? Let's find out with another variant of Newton's cradle. Here is a setup that explains conservation of momentum like Newton's cradle. Here is a marble and a metal ball. Let's see how they react to each other when they collide. If the lighter mass is stationary and the heavier mass has certain velocity, it drags the lighter mass along with itself. If the roles are reversed and the heavier mass is stationary and the lighter one has a velocity, it barely pushes the heavier mass. Now, if both of them have a certain velocity, which let's assume is the same, let's see what happens. The lighter mass gets pushed out. Momentum of an object is due to its motion. Hence, if velocity is 0, momentum will also be 0. Acceleration, as you have learnt before, is the change in velocity per unit time. According to Newton, the force required to accelerate an object depends on its mass and how much acceleration we want to acquire, that is F is equal to ma. This is Newton's second law of motion. Force equals mass times acceleration. In the Newton's cradle, the force we are applying on the marble is dependent on the mass of the marble and how much acceleration we want to acquire. Thus, we get an answer to our question. Full shopping cart has more mass. So, in order to accelerate it for moving, we have to push it with more force. Will you be able to tell now if your weight and mass will be the same on moon as it is on the earth? Well, your mass will be exactly the same because it is simply the matter that is inside you. It will not change anywhere in the universe, but weight depends on the gravitational acceleration of the planet you are standing on. Gravitational acceleration of earth is much higher than that of the moon. Naturally, your weight on the moon will be much lower, 6 times lower to be precise, than on earth. If you want to make your own Newton's cradle, click on the link below for detailed directions. Now, we will perform another interesting activity. Here, we have two plastic balls, a thread and a needle. Let's sew these balls into this thread. After sewing the balls into the thread, we get a setup that looks somewhat like this. Both these balls are of the same mass, approximately the same size, and they are kept at the same height. If I take one ball away from its rest position and release it, what do you think will happen? We can see that the balls are striking on each other and being of the same weight, they are bouncing back at the same distance. This is because their mass is exactly the same, hence they bounce back at the same velocity. Here, assuming the collision is elastic, the momentum is conserved. Now, if I remove one plastic ball and replace it with a heavier ball, what will happen? Now that masses are different, the velocities at which they bounce back also changes. This proves that the momentum is always conserved. Do you want to learn Newton's second law of motion by making your own jet car? Join with me. Here's a jet car. For detailed instructions about how I made this, click on this link. If I inflate this balloon exactly the same, but this time place some weight on the car, what do you think will happen? As we added some coins on the car, the weight of the car increased. The applied force on lighter and the heavier car were the same, but the acceleration of lighter car was much more as compared to the heavier car. In this video, we learnt about Newton's second law of motion. Join with me in the next video to learn about the third law of motion that Newton put forth. Thank you.